If you've been watching my channel, you may have seen in a previous video, I built an Arduino load measuring system for my Arbor Press. The purpose for this system was for my students in class to run an experiment on a variety of infill settings and densities in the classroom. To summarize that really briefly, the experience that I've seen has been absolutely amazing. The students have really got on board with this experiment, and they appear to have really been getting something out of this. Because that has been so successful, I decided I want to follow up on that and share with you a few different ideas that I feel like I can explore using that same system as the base principle for measuring the amount of load that a 3D print can handle. I want to start a new playlist of videos that I'm going to be making over the next year or so. Today, I'm going to share with you something I didn't share in the first video, which is how can I calibrate this measurement system so that it's actually giving some sort of accurate measurements. For the sake of what the students have been doing in the classroom, the actual numbers that the students have been measuring are less important than the insights that they're gaining by taking those measurements. But the truth is, the numbers that they've been using have been very, very inaccurate. I did account for calibration in my code. I just never did any calibration in the previous video. Today, I'm going to share with you the simple process of calibrating my Arduino Arbor Press. As I did in that previous video, I'll also upload the calibration sketch into the description in a Google Drive. So if you are following along with this project and would like to make your own copy, you should have everything you need there to make it happen. Here's my load cell calibration tool. This should allow me to get a calibration factor that is accurate rather than the guessed value which I put into my previous code. So I'm going to upload that now and open the serial monitor. I'm using 5 kilograms here as my known mass. My calibration factor is 22,010.52, and this is where I'm going to place that calibration factor in the code. You'll see there that my calibration factor was well out. I'm going to place that value in here now and upload that code to my Arduino. Now I should get a more realistic result. You can't see this, but I'll show this a little later when I get back out to the garage. I'm going to place 5 kilograms on there. I'm now registering 48 newtons of force. Let's see, 5 times 9.81 equals 49 newtons. So that sounds about right. This is my new Arbor Press, and I haven't mounted any brackets on the bottom of it yet, but I will be doing so soon. The differences is I've made this with a slightly longer cable on the load sensor. I've actually calibrated the load cell with a 5 kilogram mass. I've shared the process of how I did that earlier in the video. All that's really left for me to do is get my mounting system set up. Then I'll be able to share with you some engineering concepts using 3D printing and my Arbor Press. That's all set to come up over the next 12 months or so. I look forward to bringing that to you, along with the continued progress on my Triumph and any other little jobs that I might happen to be doing out here. Until next time, see you later.